Grabby Aliens are a version of the kind of aliens that would, if they show up, take advantage of their environment and improve themselves as a result of it. Should we hide ourselves and be quiet and not let other aliens who are grabby find us and take our natural resources from us?
If a grabby alien showed up here, I'm kicking its ass.
As long as they have one. Right.
This is Star Talk Special Edition. Neil deGrasse Tyson here, your personal astrophysicist. And it being Special Edition means we got Gary O'Reilly. Gary, in the house.
Hey, yes, in the house.
In the house.
Yes.
Former soccer pro. Love your wiki page with your sexy legs.
You're looking too much. Stop it.
Excellent. Chuck Nice, always, man.
Hey, what's happening, guys?
Yeah, all right. So we brought in our geek in chief for this.
Our returning hero.
Our return. Charles Liu. Charles, welcome back.
Thank you so much.
You've got your own podcast.
Yes.
The Luniverse.
The Luniverse. About to
That's
start.
clever. That's clever.
Now, is that a play on Luna as in moon, too? I mean...
I can't take credit for it.
you didn't think of the name?
No. I'm sitting at the table for dinner, right? And we're like, well, what do we call this podcast? And our youngest kid says, The Luniverse, of course. And I was like, what?
Well,
There you go.
And that's it.
Don't overthink it.
Okay, so compared to your kid...
Wait, and then Chuck went like this. It's a dumb idea. And then he named it the Luniverse.
I said no such thing. I just sort of said, wow.
So I happen to know your wife is really smart, so it sounds like your kids are even smarter than both of you at this point.
I am so pleased that my wife and my children are all way smarter than I am.
Yeah.
And it is a great privilege to be able
You know what
to
Michael
say
Dell said?
What?
The day you wake up and you're the smartest person in the room,
Right.
change rooms.
Exactly. Very, very better.
Gary, before you introduce the show, Chuck, what are you wearing?
Today, I am mostly
I
wearing...
feel like I'm on the worst red carpet ever right now. What are you wearing?
And your hand was in your groin a half a second ago. Could you pull your smartphone out of your groin?
That's not my smartphone, Neil. No, I'm joking. Okay, here we go.
What's...
So we were playing a little softball earlier today, and I don't believe in showering. I do that once a week, and that's it, baby.
And only if necessary.
And that's only if necessary. And so, you guys changed, and so I'm like,
You did not change.
I'm not changing.
We look clean.
Yeah, you look clean, and
You still got your leg braces on?
Those aren't braces. Those are, what do you call them? Augmentations that were placed in me by DARPA. Yes.
You are now a superior augmented human being.
That's right.
Right. Amazing.
Don't ask me to jump up and get nothing off the roof because I can do it.
That explains why you were tearing around the bases so fast. It was amazing.
And DARPA, Defense Advanced Projects Research
Agency?
The Defense Advanced
Authority?
So this is a branch of the military.
Yes, it is.
That people might not know, where there's a subset of budget that goes to very high risk projects that probably won't work, but if they do work, they'll be amazing.
Yeah.
And so
nothing is higher risk than Chuck Nice.
So they expect a high percentage of the proposals to actually
fail.
not work, to fail.
And they don't care because the idea is
learn.
the one that works is going to make us badass.
DARPA.
Yeah.
Gary, what you put together for today?
All righty. So these are questions from our Patreon listeners. And as you know, they have a curiosity that is almost endless.
Boundless.
Yes. So let's kick it off.
So this is Cosmic Queries.
For sure,
Yes.
it's a Cosmic
All right, let's
Queries.
do
Yeah,
it.
it's a grab bag. And we had 42 pages of questions.
Ooh.
Whoa.
Well, we
So-
better shut up and get
All
to
right,
it.
but they're not all on there, but thank you so much for your curiosities. Right, let's start with Danielle's. Hello, Neil, Dr. Liu, Gary, and, of course, Lord Nice. Could quantum particles possibly be connected in a higher dimensional space and only appear to be separate particles in 3 dimensions?
I love that.
Would a connection like that affect quantum entanglement? Over to you, gentlemen.
Oh my God.
I thought you were going to take that.
Oh, yeah. I'll see how well you do.
Well, I'm going to defer to Charles, but I'm going to introduce this. Okay?
Tee Charles up.
Because we see particles popping in and out of existence and tunneling through space and time, and we're trying to make sense of it. But I don't see why a higher dimension wouldn't help that out. For example, suppose we all lived in just a plane, a flat with 2D people, okay?
You know some of my friends I see.
They have no depth.
Yeah,
They have
no depth at all.
So we're here, and then like a dot shows up, and we all gather around the dot. And then the dot sort of becomes a circle, and it slowly grows. And we get our top scientists to analyze this. Where did this come from? What is it? What's happening? And then it shrinks back to a dot and then disappears. We would invent a whole quantum physics to try to understand this, when all it is somebody passing a sphere through the two-dimensional plane in which we live. Because the first contact is the point, and then there's this circle. As you go through, it maximizes at the diameter, comes back out. But here we are touching, we're thinking there's something magical, and from 3 dimensions, it's completely simple. So Charles, this question sounds like, let's up the game. Can we explain all this mystical, magical quantum spookiness by just it's ordinary people in 4 dimensions playing marbles?
Not only can we do it, some people have already tried. It's called string theory. The idea is that every particle we see in 3 or 4 dimensions here might actually have many more dimensions attached to them. And interactions on those other dimensions, like the sphere with our particle, but imagine 2 spheres interacting not on our 2-dimensional world, and bingo, you have additional weird things happening. So you, Danielle, are right on the cusp of exactly what physicists have been trying to figure out for decades. Is there perhaps another explanation where we can say the reason this thing is acting so weird is because there's connection elsewhere? Now, the problem is...
How do you test for that?
Right. We can't have any good experiments.
Because we can't access those dimensions.
And there are so many... Yeah.
And you're like, and we never will, thinking that way, Chuck.
Don't be such a downer.
There are so many different ways to think about it that you can have essentially an infinite number of solutions to a finite number of questions that we see or phenomena that we observe here in the world. So we don't want that. So the more a theory is simple and the less it requires additional pieces attached to it to explain observed phenomena, the more likely it is to be something that we can test and confirm. So that's what's going on here.
And history says the more likely it is to be right.
Generally speaking, that's right. I mean, the famous term Occam's razor, right? Just the philosophical...
I'll tell you exactly what he said. He said, multiplicity ought not be posited without necessity.
Right.
That's the actual quote from Occam.
Right.
And that we convert that to just his Occam's razor. Just
the simpler idea is more likely to be true than the more complicated idea. That's only a philosophical idea.
Yeah, exactly.
That's not exactly confirmed in every instance.
Nature doesn't have to obey you in
So
that regard.
in this instance, that's right. It could well be that that helps to explain quantum entanglement. But entanglement is yet another phenomenon, which is a little bit odd, and we're still working on that. I know right now it's a hot topic, and there are a lot of people talking about it.
Working on it.
Yeah, but there's still many, many questions about it. So we could relate it to entanglement, but it's not yet there enough for us to be able to answer that question, yes or no.
Or it could be like when Einstein did general relativity, where he was solving some other problem, and bada bing, the mysteries of Mercury's orbit were solved overnight. Mercury's orbit was not behaving the way Newton would have it go. And all of a sudden, Einstein's general theory of relativity just explained it without even trying.
Without trying.
And so it became a side benefit
That's right.
of it. And one thing about your negativity, okay?
Okay.
Uh-oh.
I feel a read coming on.
So I was on the Infinite Monkey Cage with Brian Cox in London.
Okay, and
That's
how
your
my
stomping ground.
how many monkeys are in an infinite monkey cage?
Let me guess.
So that's the name of his show, his podcast. It was a radio show. And so we were talking about wormholes.
Okay.
And I said, well, with a wormhole, you could do this and travel through. And he jumps in and says, well, wormhole is not stable. It'll collapse immediately. So we need to think about it. Someone from the audience, a Brit, said, that's what distinguishes Americans from us Brits. They're always so positive about what can be solved. And we're always saying what can't happen.
That's funny.
And that shut him up.
That's culturally accurate. Not always, but on a number of occasions, you will find an American positivity against a British.
Yeah,
Right.
so
Really?
yeah, so we go there.
I mean, it has its drawbacks,
Yeah.
you know, when it's just like, I'm the biggest, the best. Many people don't realize I'm the most positive.
Keep going. What?
All right, Chuck, you want to hit the second
let's
question?
do
Oh,
this one.
Chuck's got him too.
Yeah.
This is Ryan Harris, who says, Dr. Tyson, Lord Nice, Geek and Professor Liu. And Gary, Ryan Harris from Burnaby, British Columbia, Canada. Given the laws of science, if they hold true, when it comes to quantum entanglement, staying on subject, would there not be some sort of energy/force being exerted/used by entangled particles? And can it be qualified as of present? I am trying to understand how two particles across vast distances are influenced by each other instantaneously, and if there are some sort of exotic, scary, or otherwise force that has been associated with this phenomena.
So what I would say, how can a thing happen at all without there being an active draw on energy or some other thing that we can measure changing for them to be permanently connected, or while they're connected, Something's got to, some clock is ticking, something should be measurable from that.
This is one of the big differences between quantum physics and classical physics. We're conditioned, we're trained to think that there had to be something exchanged back and forth, energy, a particle, whatever, between two things. But
That's a classical
bias.
Perception.
Quantum entanglement, again, as we said earlier, is still not completely well understood. In fact, we don't even know if it's a special thing or if it happens all the time and we just never notice it.
We understand that it happens,
Yes.
and we can measure that it happens.
Right.
So what you're saying is we don't understand why.
Yes.
But you know what? Before we
That's a very important distinction.
Before we go any further, before the why and all that, somebody ought to tell somebody who might just be joining us, what is quantum entanglement? Because this person...
Just because you don't know, don't assume everyone else in our audience doesn't know.
Oh.
Okay, well, somebody should tell me then.
It's a perfectly legitimate question because even if you ask, say, 50 quantum physicists, you might get 51 different answers as to what quantum entanglement really is.
Okay, that
because
I
it's so
did not
complicated.
know.
Right. It's kind of like if you ask 100 biologists what life is, you'll get 101 answers.
Yeah.
Same sort of situation. But the fundamentals, biologists know what life is when they see it, right? The same is sort of true for quantum physics and quantum entanglement. But boiled down to its most basic point, you can basically think of two entangled particles as being one particle that somehow gets separated. But even if it's separated in space and in time, they are still the same particle. You're just stretching it. So imagine if you have a little ball and you break it in half and then you're kind of moving it. It's kind of like this quantum taffy or caramel almost that continues to connect them even though there could be a huge amount of space or time between those two parts. They are still the same particle.
And that's a quantum thing that you're describing.
That's right.
Not a classical thing.
That's right.
Because classically, there's nothing between them.
Yes.
But I'm speaking like with a classical brain to say
and
that.
we all do that. It's very, very hard for us, even those of us who have done a lot of work in quantum physics.
And just to be clear,
to think
these
that
two
way.
particles, I like the way you're saying it's the same particle, but they have slightly different properties that complement each other.
Gotcha.
To make the whole particle, right? So they have
Very well
each
said.
side took out some features of that same particle.
So is this like the twins, where if you slap one on the butt, the other one goes, ow?
Sounds like you've done that.
I think that's. I don't want to say that's true, but I think that's true.
That requires an additional assumption about classical
Whether
physics of
particles have
twin
butts.
butts, interacting with quantum butts.
Okay.
And then you have some real issues.
So do we get to the point where we say the universe is one single particle and that's just all of a sudden done its thing? And it's
Great question.
Yeah.
We are definitely not all one particle, but the universe could be one single entity that contains a multitude of very, very small, more complex parts. This is something that happens a lot. We think of, for example, atoms as being some sort of indivisible piece of matter. But then we've learned
Well, the Greeks
since,
thought that,
right, we've learned since
Atom
that
means
atoms,
indivisible. That word in Greek means indivisible.
Nice.
we've learned since that atoms are
Did you
made
know
up
you
of
didn't know
The Greeks any good at anything?
that? The Greeks sucked. Those idiots.
They did pretty well in the World Cup back around 60 years ago, right?
No, they won the European Championship
That's right.
a few decades ago.
Yeah.
But I
And
am
the democracy thing is overrated,
being
you know.
facetious. Right, should we jump into the next question?
Yeah.
Let's go
All right,
for it.
for it.
Ezekiel Reeves. Hello, Neil, Chuck, Gary, and Lord Lou. My name is Ezekiel from Wawa, Ontario. I love this
But it's
already.
not Lord Lou. It's Geek in Chief Lou.
Okay.
I accept
No.
any title
No,
anyone wishes to give me.
adjudicate titles here.
Okay, Doctor. So, quantum
Okay.
physics is rooted in observation and particles deciding which state they are in depending on probability. Can this explain how we evolved the conscious mind and free will?
Wow.
We
Don't
went
you have
there.
4 hours?
I did not see that coming.
Oh, yeah.
Oh, no. That's great. The key question in my mind, based on your question, Ezekiel, is the word deciding, right? The decision of something to go this way or that suggests that there was something behind the ultimate outcome, right? When you and I decide to have a ham sandwich, or we decide to...
No, I want one. No, you said it.
Yeah, right. Or we decide that we're going to dive left for a penalty kick instead
Okay.
of dive right. That has a whole bunch of stuff behind it. And the causality of it is dependent on everything from the goalie's life experience to the muscular twitches of that very moment and everything in between. So when individual particles are switching or landing in certain states, Niels Bohr would have called it the wave function collapsing, right?
Niels Bohr, a physicist from 100 years ago.
Yeah, when you have that kind of an interpretation, then you can ascribe, perhaps, intention, right? But we just cannot say, even now, we still don't really understand what free will is. The definition of it varies from person to person. The
You know how
philosophical
you know we don't know what it
ideas.
is? Because people are still writing 500-page books on it.
Sure.
That's the evidence that we don't know anything about it.
Right.
Interesting.
Yeah,
But keep going there. So
Okay.
we've got quantum probabilities
right.
so that a particle, quote, decides is it going to decay or is it not.
Yep.
And we know that probability precisely. That's
Yes.
what's fascinating.
That's right.
Here's something that's completely probabilistic that we know with precision. It's a weird combination of facts there. All right. So
Right.
you're not prepared to analogize. I love the thing, the goalie leaning right or left to the particle decaying
Right.
in one moment or another. You're not prepared
Not yet.
to have your free will be a similar kind of expression.
That's right. Because that's the problem, right? If you decide that free will is something where, say, we humans decide to do a thing,
Yeah.
right? There's a whole host of events that happened before that moment that helped us to make that decision.
And there's also a number of events that lead up to the moment before the event that also influences that.
That's
Isn't
right.
that what he just said?
No, he was talking about immediately before the event. Like,
It's okay.
yeah.
Yeah.
But
yeah.
Okay.
so I'm saying that you can take that all the way down. You can keep slicing those
it up.
layers all the way down.
Turtles all the way down.
That's right.
Turtles all the
And-
way
yeah.
down.
Okay, so
And there's-
and there are those psychology experiments.
That's right.
Where they put probes in the brain. I'm going to mess up the details here, but the results are what I'm landing on, where they can trigger you to stand up, and
Whether you want to or not.
Then you're standing up. They say, "Why did you stand up?" And then they make up some reason for why they stood up. When the neurosignatures, the neurosignals, already were prompting him to stand up, and he made up a reason after the fact.
And they were so the signals were generated externally, but you internalize it and say, "Oh, I stood up for this reason."
So you think you had free will to do it,
Right.
when in fact it was predetermined. That's spooky.
It
So
is.
you talked about probability and the certainty of
Yes.
probability. What is it? Heisenberg's
Uncertainty
principle.
So where does that fit in? Because you don't really.
I'm not certain about that.
Well, I didn't expect anything else.
Heisenberg's uncertainty principle. That's a great question, Gary. It actually has a little bit.
Werner Heisenberg, German physicist, once
Yes.
again, from 100 years ago.
Right.
Yeah.
It has a slightly different connotation because what we're saying is that we cannot measure things precisely with infinite precision. That uncertainty describes how much you don't know, no matter what. So Heisenberg's uncertainty principle is actually describing a minimum amount of uncertainty in any measurement.
Any measurement.
Not necessarily
Not a case of
uncertainty
we don't
about
know.
about
Maybe
what's
we do
going to
know.
happen or
Yeah.
what's going to happen or not going to happen.
And part of that is because I can know that you're sitting here, and the measurement of that is completely sufficient for anything I might do to you or with you. But when particles are involved, which is the whole world of the quantum, if you try to measure it, the act of measuring it changes what it is you're trying to measure.
Right.
Yeah.
Right?
Yeah.
So the interaction with the particle confounds your ability to measure what that particle is doing with precision. And I think that's foundational. That's what's foundational. That was so hard to accept by classical physicists.
Well, that's hard to accept by anybody.
Any step of science going forward, whether it be classical quantum, has been hard to accept.
Yeah.
It takes time, and we should allow ourselves that time. Don't feel
To
like upset.
quote, was it?
mad.
Yes, it was Max Planck, was it? Who said, no great I'm paraphrasing, no great discovery in physics gets accepted by the guard of the day. They just get old and die, and the next generation
takes their place.
takes it on as though it has always been.
Well, the cosmological constant might be an exception to that.
I know, but he predates the cosmological constant in that quote. But anyway, go. What you got?
I'll go with the next one. George Valakis, back with the Greeks.
Hey.
From New Jersey. Can someone please tell me what a qubit is made of?
Aha!
Is it an electron stuck inside some type of magnetic box? Is it an atom with multiple electrons frozen in multiple quantum states? How is one made?
What a
Love
wonderful,
Qubits.
Wow.
wonderful
That's a great-
question.
Thank you, George.
But let me just,
George,
let
great
me just
question.
preface this by saying our geek in chief in the past year published an entire book on quantum physics. What's the title of it?
The Handy Quantum Physics Answer Book.
There you go.
Right?
There you go.
So we're not going to answer your question. Just go buy the book.
and we can go have a beer right now. Okay?
Give that back.
Buy the man's book, and then we can all just have a beer. Okay. The Handy Quantum Physics Answer Book.
Yeah,
Man.
It's not designed to be a textbook or anything like that. It's
But that's
just
still-
if you have Q&A,
That's
if you don't know stuff.
to put with a title like that. Just
Well,
telling you.
again, I cannot claim actually having made any of those discoveries. I was just trying to put together a little guide for people who had questions and answers, and they are
a little guide
explaining
for your quantum questions.
Yeah,
as one would have.
It'll help someone come along and hold your hand. Just
Okay.
walk you along.
It's great, amazing stuff that our colleagues have done over the centuries.
Yes.
And this year being, of course, the 100th anniversary as designated by the United Nations of International Quantum Physics.
Did they declare that?
Yeah,
Very
the
nice.
International Year of
Right
Quantum
in the
Physics.
middle of the decade. Yes. The whole decade goes to quantum
Yeah,
physics.
it's really quite amazing.
Yeah.
So a qubit actually doesn't need to have a physical form. It's a piece of information. Let me make an analogy to regular bits. Okay, bits are just pieces of information.
Right.
So, for example, if you've got a 64-bit chip in your computer, all right, all that is that it can carry or hold 64 pieces of information that are either 0 or 1. If you have a bit, it's just a piece of information, and you can store it either electronically in a chip, with a plus 5 volts or minus 5 volts or something like that. Or you could, say, store a bit of information in a QR code, which is just a square that's white or a square that's black. Or you can do a coin flip, whether it's heads or it's tails. So the bit...
With the QR code, that's the little thing we scan.
Yeah, the little
square.
scan thing with the
Yeah. I always thought of that as like a two-dimensional barcode.
This is exactly what it is.
Yeah, because barcodes, are you white or black? And how thick is the black?
That's right.
And that's all the information.
That just
and you
was
scan
across the one dimension, right?
Yeah. So I presume because we added a dimension, the QR codes can hold way more information
With the same amount of area.
than a barcode.
That's right.
Linear, yeah.
So you have QR codes that have entire web addresses on them.
Yes.
Right.
And they can be little bitty things. But in the end, it's just squares. So square that's white or square that's black, square that's white, black next to each other. And that is the information. So the bit is the information. It's not the thing that it's stored in. So George, your question, what is a qubit really? It's a quantum bit, but it's a piece of information. And you can store it in any kind of container that quantum systems can hold this information in.
Didn't Microsoft just bring out a quantum chip
They tried
within the last
yes,
few days?
That's right. It's the very beginnings of using quantum computing in regular computing that we're used to. But they are far, far away from a true quantum computer.
Okay, you just said that it's not a thing, it's information. But
That's right.
Now tell us the difference between a traditional bit, which is a 0 or 1 or
Yes.
black or white, and a qubit, which is a statistical
Right.
occupation
So the- yeah.
of a. So just go there.
Okay. Well, a bit is either a 0 or a 1.
Or black and a white.
Black
Yeah.
and a white.
Yeah.
Just a piece of information that is or is not.
So it's binary.
And so it's a binary piece of
Binary,
information.
thank you.
Right. The qubit is binary when you read it. But before it becomes read, it is not yet settled. So it can be somewhere between 0 and 1, and the complexity of the amount of zeroness or oneness a qubit has fluctuates and varies until such time as you read it. Right. So if you have a computer nowadays, we want to make a bit switch as quickly as possible. All right. So we want our computers to switch from 0 to 1 or 1 to 0
speed of the computer
as fast
is
as you
embedded in
can.
that, yeah.
Right. With a qubit, you might want to slow it down a little tiny bit. And while that stuff inside the qubit is settling out, it may actually be able to make calculations. You can actually ask the qubit using various electronic inputs to give you a number doing some sort of a calculation or some sort of a figuring that you could not do in real time at high speed. And because the quantum time frame is so fast, even if we slow it down, you still wind up being able to do certain calculations way faster than any classical computer
So
can do.
probabilistically, you're no longer bound by the binary.
Yes. During the time in between the 0 and the 1, you've got a chance to really mess with it
Right.
and really gain some new knowledge that you couldn't have done before.
So the moment you read it, all that's over.
That's right.
Because probabilistically, you are now back to the binary.
That's
It either is or it is not.
That's right. And so what you're trying to do when you're creating a qubit with technology is to figure out how you can sustain that qubit, how you can make it last for a tiny fraction of a second longer than otherwise would, or what you can make that qubit do a calculation for you, which you can't watch.
Why can't I make a VR code qubit that has a grayscale in it?
Eventually you could, but right now we don't have the technology.
Because that would be everything between the 0 and
Exactly.
the 1.
0 and
Right.
1.
Yeah,
So-
the black and the
And
white.
on a grayscale.
That's right.
That'd be amazing.
That would be awesome.
That would be amazing.
But we're not anywhere near there yet, but the technology is getting us there slowly but surely.
It's called
The
black and white
electronic
photos.
stuff.
That's all it is.
Yeah, but this is why they say like encryption ends when we have a quantum computer. And it's because all of those possibilities you could actually figure out,
Manifest
it inside of that, inside of those qubits kind of all at once.
That is very similar, yes. You have right now, the way we keep our internet connections secure is through a particular kind of algorithm or strategy. That strategy can be broken according to the theoretical calculations if you have a quantum computer.
It's an encryption.
Right. The only thing is, once that code can be broken, can we make another one that can't be broken?
That can't be broken.
Right.
Gotcha.
So there will always be this race.
So now you got quantum encryption.
That's right.
Okay.
And this and the back and forth. Those are some really interesting stuff.
Yeah.
Yeah, George, thank you for that. I think we've learned a lot from that answer. James Kovacs, hello, gents, from Detroit, Michigan.
We said it right. Detroit.
I know, I'm getting there.
You said
I'm
it like a
getting
black
there.
man.
But did you say
From
Kovacs?
Detroit.
Correct.
Probably didn't say Kovacs. Kovacs, yes, sorry if I'm mangling. So we know speed and mass cause time to slow down. In the case of speed, we know the universe's speed limit is the speed of light. You may disagree, you may not. Time stops altogether at the speed of light, and nothing can surpass that speed. Is there a similar mass limit? Is there a point at which you have so much mass that time stops?
Let me make first just a tiny bit of adjustment to the question.
Sure.
The assumption is that the faster you move through space, the slower you move through time. It's not that time will stop if you are moving very fast or at the speed of light, right? The speed limit.
is relative.
Everything is relative. So that question has a little bit of a nuance to it. But to answer that basic question, is there a mass limit of objects? The answer is no. You can make an object of arbitrarily large mass in the universe, and that would be totally fine. But there is a limit, because if you have too much mass in any given location in the universe, you create a Schwarzschild radius, which is the outer boundary of a black hole.
Okay.
So the way to think about a maximum mass in the universe is to think about the maximum amount of mass that can fit inside a limited volume. Okay.
And not be a black hole.
And not be a black hole.
I was going to say, because don't black holes, isn't the idea of a singularity as unlimited volume inside of no limits on volume?
Great point. A singularity is defined as something that has no volume,
Right.
but infinite density because it has non-zero mass. However, a black hole,
Just to be clear. So density has volume in the denominator.
Right.
And if the denominator goes to zero, you're dividing by zero.
And there you go.
There you go.
and that number doesn't exist
right.
in our mathematical
See,
system.
and so now this is what I'm going to say. Why y'all been lying to us all these years, man?
About what?
Y'all, everything. You just
Okay. Sorry, dude.
No, I'm joking. That's a joke.
But the situation really is that if you add more mass to an object,
Right.
and it's already at its black hole mass limit, it just gets bigger.
right.
The black hole itself gets bigger. Inside the black hole's event horizon, you could have an incredibly massive object or a singularity or something like that, but we will not be able to know because information cannot pass through that event horizon, at least as far as we know now.
Yeah.
All right.
The cosmic blood-brain barrier. That's what I call it.
Excellent.
Ooh, very
I love
organic
it.
of you.
Yes.
Right.
But does that mean our brain is inside the barrier or outside the barrier?
It depends on who you are. All right.
That was
Keep
good.
it going.
Next one up comes from Raluca Alexandrescu, formerly of Bucharest, Romania, but now living in Toronto, Canada. My question is, how would we study the universe if light traveled at infinite speed? Yeah, I knew you'd like this
I
one.
love me some infinite
Yeah.
speed.
Okay.
If,
So-
it goes
there's
on.
more. Okay.
There's more.
All right.
If we lived in a universe where the speed of light was infinite and we did not have the benefit of seeing back in time as we look into deep space, how would the study of the universe change? Would other laws of physics be changed if light traveled at infinite speed?
And let me tee this off, and I'm going to pass it off, pass the baton. If the speed of light were infinite, we would know nothing about the history of the universe.
Because we couldn't.
Okay, we would. The Big Bang would be forever lost in time because there's no time lag from things that happened 14, 13 billion years ago. We need the finite speed of light to know anything about our past. It would be like in geology, where anything just got in sedimentary rock, it just dissolved or disappeared and removed all record of anything that had happened before.
So the universe wants
that would be a
us.
sad universe.
The universe wants us to know.
Wow.
Ooh.
Look at that.
This is deep in. You got your white robe on here.
Yes.
This is very.
I'm not actually sat in this chair. I'm actually levitating just a bit out of this seat.
So that would be sad to me if we lose all of that knowledge and information. Charles, you have any other insights here?
I don't know how sad it would be. It would be different, that's
Yeah?
for sure.
Yeah.
Our ability to tell time would be essentially wiped out. That's what Neil is saying. And that's kind of a trouble.
Well, tell history time.
Yeah, right.
I can know it's 2 PM. I could know that.
The causal time gets messed up.
But
right?
it's just
Because
us as a species that registered the concept of time.
Not at all. We know that there are many species that can tell difference between day and night, for example.
Yes.
Right? And they actually age and they know when to spawn and when to come back to the stream. So they do measure time, but not in the way that we understand it as ticking and so forth, right? But clocks here on Earth, if the speed of light were infinite, would also run funny. There would be a ability to see things that are happening, but the way that we measure them is dependent on how fast that information gets around the universe. So there's lots of interesting, cool results. I don't know if they'd be sad, but it certainly would be very, very different. But I'm going to focus on something that's a slightly different, and I got to give credit to our former colleague Ken Croswell.
I remember him.
Yeah, Ken Croswell was wound up writing a number of books about astronomy. Also, a very, very talented astronomer. He wrote a very good insight that I saw in one of his books, and that is, if the speed of light were infinite, night would always be day.
Good point.
Because the light from distant parts of the universe would get to us immediately, as well as stuff close to us. As a result, every single spot in the sky would be
just
covered
coming
somewhere
up
by a star.
Right.
Yeah.
Right?
Wow.
So all the lines of sight in the universe would be
full of
brightly
light.
lit. And so we would never have a sky that we could look at night and see what's out there. So that's the most fundamental difference in our study of the universe.
But wouldn't an expanding universe still dilute the light, even if it traveled
If the expansion rate is finite, and the speed of light is infinite,
It doesn't matter.
then it doesn't matter.
It doesn't
Catch it.
Right. It will never catch
Can't
up.
win.
That's right.
That's right. So there would be no
So
night.
light outraces everything
Yes.
all the time.
If it were infinite,
Yes.
that would be it.
And if memory serves, the fine structure constant has the speed of light in it.
Yes.
I'm sorry, you lot. What?
It's okay. So the universe has among its several constants, speed of light is one of them.
Right.
Some constants are combinations of other constants.
So the fine structure constant.
It gives us information about the formation of energy levels inside of atoms.
Okay.
And so if that were infinite, what does that mean?
All right, we got to do an explainer on the fine structure
But we have to bring Geek in Chief back for that.
Well, it actually has a really interesting history because for a period of time in the history of quantum physics, the fine structure constant was measured to be exactly 1 divided by 137. And no one knew why 137 was this magic number. And today we know that that was actually an approximation. It's off by a tiny, tiny, tiny fraction. But that's something fun to talk about in the future and about the advancement of history and how we tried to create ideas.
Isn't it 1 over 137.16 or something?
0.00 blah, blah, blah.
Oh, it is that
yeah,
clean.
It's very,
It's
very
flat in
close.
there. Okay.
Yes, yes.
All right, so that's another thing. So it could mess with other stuff as well.
Okay.
Because the speed of light shows up in our calculations.
Right.
And if it's infinite, what does that do to the calculations? And
Oh,
our understanding of
blows
what's
them out.
I see what you're saying.
Yeah.
You change everything.
Yeah.
Yes.
Oh, that's so wild.
Just
You
saying.
can-
Yeah, blowing stuff up now.
Yeah, you really have to.
You blow up the system.
Oh my God, that's
Yes.
right.
And it almost doesn't even mean anything to say the speed of light is the limit.
Right.
Because if it's infinite,
There's
the
right.
relativity doesn't
Fails.
even make sense.
That's
No longer relative.
Albert Einstein's theories
That
are
was
not
good.
useful.
It's no longer
It's
relative.
no longer relative.
That's right.
Right. And simultaneity would be real.
You
Things
actually
can
would have
happen
things happening exactly
simultaneously.
at the
We could all
same time.
experience it.
Wow.
We've just
That's
we've just
so
put the notes
It's
down
good
for
stuff,
a
right?
screenplay
Yeah.
for another movie.
Okay. Yeah. Oh my gosh.
Yeah.
Yeah.
What
It's kind
if?
of fun though to think of the whole
speed of
universe
light were
bathed
infinite?
in light, though.
Yeah,
the
it
entire
is.
universe would
Well, we
just
kind of
be.
already are, but it would be
Well,
more
but-
intense
but-
than
yeah,
your.
it would just be- yeah.
You're right. That's a screenplay that we got to work on.
Yeah. That's ours.
Let's
Hands
start
off.
tomorrow.
You know who I'm talking to.
So Gary,
All right,
couple minutes left.
All right. Mahawi Gerezia. Apologies if it's mispronounced. Time is impacted
Chuck
by
never
extreme...
apologizes when he mispronounces.
Because it's a
Mahawi's-
privilege to have me mispronounce your name. Better be happy I even said it. Anyway, go ahead.
Mahawi's from Dallas, Texas. Time is impacted by extreme gravity, like with a black hole, and extreme speeds. Do these things have something in common? For example, is the extreme gravity really just making things move faster, and that's why they both impact time?
I think the question you're asking is indeed answerable thanks to Albert Einstein.
Well,
Because
just set it up again. So two things can slow down time: the strength of your gravity field, and how fast you're moving.
That's right.
Relative to observer.
right.
So
But
they feel different, but are they different?
the thing is, they're not actually slowing time for the whole universe.
Right.
It's just slowing the amount of time or the rate at which time is being experienced by the object that is either moving very quickly or the object that is in a gravitational
Because
field.
time is the same for the observer.
That's right. So
In both cases.
In both cases.
So in fact, what's going on is it's the effect is on space-time. It's that gravity affects space-time in such a way that if you're in a gravitational field, you experience time more slowly than if you were not in that field. So you have the same effect if you're moving faster. You experience time more slowly. But the effect is not on you as the object or on time as the dimension.
Right.
The effect is on space-time overall. And
Which
Albert
is why
Einstein...
it literally slows down in the measurement, okay, which is why, if I get this right, please help me out. Particles actually decay slower as they approach the speed of light.
Yes.
So it's not the perception of time, it is a literal slowing down for the object that is approaching the speed of light.
Absolutely.
Okay.
Yes. It
And
was
So it's
what-
space-time.
I'd like your angle on that, because what that even says is it's not even what's happening inside you. It is your place.
Yes.
In the space-time
It is your
continuum.
location that
Your
makes the
location.
difference, and the rate that you're changing out of that location, otherwise known as speed. Right.
That's crazy.
But yes, your statement about the decay of particles was actually one of the most important confirmations, experiments that was done to prove that the special theory of relativity was correct.
Yeah, because a particle has an expected decay time.
Right.
And very precisely measured. You accelerate that puppy, takes longer to decay.
Yeah.
Right.
Something happened inside
Something
there.
happening.
Yep. And a fun fact is, we've said this before, but now it has foundational context. Our GPS satellites are not on Earth's surface with us. We're in a higher gravitational field than the GPS satellites. Right. So that has their time tick faster. However, they're also fast in orbit, which would have their time tick slower. It turns out the gravitational well is a stronger effect on the time reckoning
than the speed itself?
Than the speed.
Okay.
And so that, in fact, GPS time is ahead of us, and it has to correct with Einstein's relativity before it sends to the cell phone towers. So we have the time that is our space-time, the surface of the Earth, not its space-time up in middle Earth orbit.
Wow. Without regular...
And is that an adjustment between the speed and the gravity well?
Yeah, they calculate. We got top people.
We got people?
I got people.
All right. That's good to
I
know.
got people.
Yeah.
Hey, Harry, listen. Something's wrong with your calculations, man.
Neil, just for future reference, middle Earth orbit is what you go around like orcs and dwarves and mountains.
What about second breakfast?
Yes.
Medium orbit. Medium Earth orbit.
What'd I
is
say?
What you get.
Middle
Earth orbit.
I think middle's better. I'm sorry. I like it when I hear people say middle Earth orbit instead of medium Earth orbit.
Well, the middle Earth orbit is reserved for the Hobbit Space Telescope.
Oh, good one.
I like what you did there, Chuck. I got to tell you.
Okay, so I have to say medium? Or
No.
It would be better.
I'll just say Mio. There's Leo and Mio.
Mio.
It's
Leo, Mio, and Geo.
Leo,
So
Mio, and Geo.
I knew you'd get there soon enough.
That's
I knew
like-
you'd cover it.
The triplets.
Here's why I don't have
If
a
I had
problem
3
with
kids and they're triplets, I call Leo, Mio, and Geo.
Really?
Yeah,
Oh.
I would totally call them that.
I would call them Huey, Dewey, and Louie.
That's too old.
Yeah.
Really?
Yeah, those are the chipmunks.
Yeah.
Huey,
No,
Dewey,
no,
and
no,
Louie.
no.
I would call
Those were the ducks.
I would call them Dewey, Cheatham, and Howe.
All right. Law firm.
We got one.
Last question.
Okay,
right.
one more. Okay,
Here we
this from
go.
Doug D. in Danbury, Connecticut. What do you think about
who's this?
Doug D. from Danbury in Connecticut?
Doug D. from Danbury.
What do you think of the Grabby Aliens theory? Is it similar to the Dark Forest Fermi paradox solution as depicted in the 3-body problem books? Do you think it's just one example of an opportunity for speculation?
Grabby Aliens? What is that?
What a great question to end this episode on.
I knew you'd like it.
The concept of the Grabby alien. First of all, just to
I've never heard
clarify
of
for
this.
everybody, right?
Well, then you're gonna learn
Grabby
something.
is a word that was invented for precisely this. Grabby, as in aliens that want to grab things, not crabby aliens. Okay, and actually they invented the word grabby, the people who sort of are trying to talk about this, so that they would not ascribe any kind of emotion or ethics or morals to these aliens. It's just that they have a tendency to want to expand, and wherever they go, they tend to want to take things, natural
so they're
Resources.
Here we go again.
If
That's the So colonization has one sentence. Is that yours? It's mine now. Okay, that's colonization.
there is a colonial, imperial kind of connotation to this, right?
course.
Because what do we say when we want to go live somewhere else? We colonize Mars, right? That's actually not what we would want to do in a moral environment or an ethical environment. We might want to live there. We might want to visit or explore or be immigrants or something like that, but we wouldn't want to colonize them. But the point of Grabby Aliens is that they don't ascribe that kind of, say, imperialistic or colonialistic kind of idea.
It's just in their native.
This is in the nature of, say, human species. If we go somewhere, we want to take a look and see what's there and use it and improve our society or improve our lives. Grabby aliens are a version of the kind of aliens that would, for example, if they show up, take advantage of their environment and improve themselves as a result of it. Okay? That would mean that if your civilization actually interacted with a Grabby alien civilization, you would have very little time between the time you found them and the time they showed up and took all your natural resources. Okay? So the interaction between Grabby aliens and non-grabby aliens becomes a very interesting dynamic of science. Should we, as a species, attempt to be grabby? In other words, be open to the universe, send out explorers and pods, and then establish ourselves as being, say, a dominant species in this part of the universe? Or should we hide ourselves and be quiet and not let other aliens who are grabby find us and take our natural
Let me tell you
resources
something.
from
If a
us?
grabby alien showed up here, I'm kicking its ass.
That would be nice, except most likely the grabby aliens that showed up would have superior technology to us.
Now, you
I'm
know
still
what's
kicking their
wonderful is there's a movie.
As long as they have one.
What's great about what you're talking about?
Alien, where's your ass?
So the three-body problem books and now TV shows and so forth
Series,
are
yes.
describing a scenario where they are so afraid, humans and other species, of being detected by other aliens that they hide themselves. And the moment that they're detected, it's not that grabby aliens are come and take their stuff. Is that actually vicious, devastating, angry aliens want to remove them immediately from a threat. So instead of trying to exploit them, they will wipe them out.
Preemptively.
So, yes. So it's not exactly, without spoiling the series, it's not exactly the same thing as the three-body problem.
As of now, there's only one season posted, right?
But without spoiling
great.
anything, the basic point is watch this and you can see
read the
one
whole
idea.
series?
Well, that's,
He has ways.
that's another
Yeah,
time.
he has ways.
It's best to think about how alien civilizations interact with one another from the sense of should we be quiet or should we be loud?
Right.
And grabbiness is just one aspect.
Here's
of
another
those things.
great movie on this subject, but completely the antithesis of what you said, and that's District 9, where they are super
right.
advanced and they come here and we're the grabbies.
Yes. Yes.
Without even, we never left home and we're still like total a-holes.
Isn't that something?
Yeah.
Yeah.
So cool. I learned something. I'd never heard about grabby aliens.
It's fun.
I'm just aliens. You come down and kick your ass. You ain't taking my stuff.
I have no problem with grabby aliens.
If actually, just as a little plug,
Sometimes you have to grab them by the alien. They let you. They let you do it. They let you do it.
there are some very good YouTube videos about grabby aliens. Not that kind of grabby aliens, but generally grabby types of aliens.
Okay.
And so I would
it's a
find them.
philosophical point.
Yes, and you can find lots of discussions
motivations
on them.
of species.
I think there's a
and the like.
channel called Rational Animations that has a whole series of them. But just look.
So Charles, thank you for illuminating.
It is always a pleasure. I love being here with you guys.
Wow.
Such great
Likewise.
questions.
Aren't they fabulous?
Congratulations
Thank
for
you.
you guys for having such
Geek in
amazing
Chief.
audiences.
There it is. So it's got me thinking if I might offer a perspective on this, especially that last question. Quantum physics, we're reminded that we can measure things, but we don't know what is really going on. That frustrates so many of us. And maybe aliens would know. Are they more advanced? And if they are, they probably do. Maybe they have access to higher dimensions. Grabby aliens, that I'm going to kick their ass if they come down here. But I can tell you this, that if aliens are grabby, and that is a feature of them all, that is a self-limiting property of their behavior. Because a grabby alien wants to grab everything they see. And if they grab everything they see, that is the spread of the grabby aliens. And then they want to grab the same thing as each other, as one another. And they would then have wars, wouldn't they? Because some other part of their grabby aliens grabbed something that the other grabby people wanted, and now it's not available for them anymore. If it's so fundamentally part of their inner soul, of their inner source of exploration and discovery. So it seems to me, grabby alien scenario would implode just the same way the European colonization scenario imploded, where you had the Dutch and the British and the French and the Spanish and everybody trying to claim land on Earth's surface, and there's a finite amount of land on Earth's surface. Eventually, they start fighting each other. So I don't see grabby aliens as a stable future of the universe. But I'm still kicking their ass if they come.
All right.
That is a cosmic perspective. It's a badass cosmic perspective. This has been special edition.
Yeah, man.
Dude, thank you for putting this together.
Oh, you're welcome, and thank you for our audience. They're just brilliant with their questions.
And Geek in Chief, we're going to follow up on your quantum insights. We're going to all get your book. Give me the title again.
The Handy Quantum Physics Answer
You
Book.
can't want more than a title like that. Come on now. Right. Chuck, good to have you, man.
Always a pleasure.
Always. This has been Star Talk Special Edition. Neil deGrasse Tyson, as always, bidding you to keep looking up.